So this section deals with vector components. So every vector in a plane is the resultant of its vector components. And so what does that mean? Well, the component vectors are the portion of the vector along each of the axis. So the components are also perpendicular to each other. If you were to look at this sketch right here, the pieces of your vector. And so when you project on one of the axes, you will see the movement of the other. And so what we're going to do is we're going to take these vectors and we're going to use some of that trigonometry that we've been practicing to break it down into its components. So we algebraically add vectors by adding those components. So when we add two vectors, we add the x movement, we add the y movement, and that gives us our resultant vector, which we've seen. And so a vector and its components can come together and form a right triangle, and this is called a vector triangle. So a vector triangle is what happens when you break those components down and use the resultant as the hypotenuse. And we have vector components. We'll have the vector with the x, and these are actually subscripts. It's just not printed correctly. So you have your vector, your x component, your vector, and your y component. So finding the component vectors resolved into its components, the first thing you do is you're going to select a coordinate system, decide what is positive and what is negative. And so often we use the coordinate plane. If we are talking about north, south, east, west, we will also label those. And then you have to decide what is positive. So typically, obviously, the right and up is positive, left and down is negative. But you can actually choose this, and you'll see in later chapters that these don't always hold true. So you have to determine at the beginning what is positive, what is negative, what is positive, what is negative on your different components. You're going to sketch the vector. And so as you are given vector information, remember they could say in standard form, they could give you this vector, or they could say 37 degrees west of south like they did here, or they could give you a true north movement and give you this same vector. 3 different ways they could give you this exact vector, but you want to sketch it on the correct quadrant as you've drawn here below. Then you're going to draw the component vectors. So we have the resultant vector that we've drawn, and we're going to draw those components, the y component, the x component, and you can see that it has formed that right triangle. Now, to find then the different pieces of it, we are going to use trigonometry. And so I will always use the x component with cosine and the y component with sine. All right, and the reason that we do that is when we break it down, we are typically going to get this piece that is actually your reference angle. And so typically you will get this piece of it, your reference angle, and in our reference angle, our x movement is always going to be adjacent, our y movement is always going to be opposite. And so when you set up the cosine of something, that is going to be your adjacent side over your hypotenuse, if you remember SOHCAHTOA. Your sine is always going to be your opposite over your hypotenuse, right? And that will equal that vector movement. And so when we look at then the sine of theta being my opposite movement, which is my y movement over my hypotenuse, which is my resultant magnitude, then you can see that to find just the y piece, we could multiply it over. And so when we multiply it over, if we take the magnitude of our resultant vector and multiply it by the sine of that reference angle, you are going to get the movement in that direction. Same thing with cosine. If you have the cosine of some angle, we want to find the x piece, which is the adjacent piece, over the hypotenuse. Well, in this case, the hypotenuse is the magnitude, the length of that resultant. If you multiply it over, you're going to get the magnitude multiplied by the cosine of that theta. And that's how you get these pieces. So you're going to want to memorize that the x component of it is your magnitude times cosine. Your y component is the magnitude times the sine. And remember that this with that bold just means your magnitude. That is just your magnitude. Remember, we found magnitude by the square root of that x squared plus y squared based on the Pythagorean theorem. So let's look. A little girl rides down a 2.5 meter playground slide that forms a 40-degree angle with the horizontal. With the horizontal is important. The girl's displacement is d, that is the vector. Find the components of the girl's displacement, and they've given us a picture here. But what you'll see is we have a slide, all right? So she's going down this slide. The length of the slide is 2.5. They want us to find the vertical movement and the horizontal movement. Well, this is opposite, this is adjacent, this is hypotenuse. And so we're going to use that same formula. We're going to say the magnitude of the vector, 2.5, times the cosine of 40 degrees will give us the horizontal movement there. And then 2.5 times the sine of 40 degrees will give us the vertical movement. And so you just plug those into your calculator. A couple things you want to make sure that your mode is in degrees because they have given it to us in degrees. So when you plug all that in, your horizontal movement is going to be to two decimal places, 1.92, we were in meters, and your vertical movement to two decimal places, 1.61 meters.